Just a year ago, the co-author on my textbook, Peter Norvig, published an article claiming that in fact we have succeeded in creating AGI. I am pretty convinced that the answer is no. I could be wrong, but the perhaps more serious downside is human extinction.
AI 공학의 교과서라고 불리우는 인공지능 현대적 접근 방식을 쓴 스튜어트 러셀. 그는 왜 함께 일했던 동료와 대립되는 의견을 제시했는지, 그러면서 멸종이라는 단어까지 쓰게 되었는지를 이번 강의를 통해 확인해보고자 합니다. 안녕하세요. 이번 시간에는 세계적인 AI 석학 스튜어트 러셀의 AI 윤리에 대한 강연을 들어보도록 하겠습니다.
So if you go back to the beginning of AI, really in the 1940s, official birthday is 1956, but it was already going before that. And the goal of AI has always been create machines that exceed human intelligence along every relevant dimension. And nowadays we call that AGI, or artificial general intelligence. But what we failed to do for most of the history of the field is to ask a very important question. What if we succeed in that goal? If we succeed in this goal, it would be the biggest event in human history.
왜 러셀은 AGI가 인류 역사상 가장 큰 사건이 될 것이다 라고 얘기했을까요? 그냥 AGI가 대단한 발명품이라서? 스튜어트 러셀은 이렇게 얘기합니다. 우리 인간이 세계를 지배하는 이유는 지능 때문이다. 문명의 결과도 지능 때문이다. 그런데 만약 우리 인간보다 더 지능적인 새로운 존재가 나타난다면 필연적으로 이는 문명의 전환점이 될 것이다 라고 말이죠. 그러면서 러셀은 그의 동료인 피터 노빅과 자신의 견해를 비교해서 이야기합니다.
Just a year ago, the co-author on my textbook, Peter Norvig, published an article claiming that in fact we have succeeded in creating AGI. It's just that, kind of like the Wright brothers airplanes in 1903, they weren't very comfortable, they didn't have a full bar, but they were airplanes. And all that's happened since 1903 is they got bigger and more comfortable and faster, but the principle was achieved. So is that the case for artificial intelligence? Do we have the Wright brothers version of AGI? I am pretty convinced that the answer is no. I could be wrong, because the AI we have now, we haven't the faintest idea how it works. The Wright brothers did have a pretty good idea of how their airplane worked, because they put it together themselves. But with the AI systems that we have now, which are giant black boxes, basically approximately 1 trillion tunable elements in a giant circuit, and we do about 1 trillion small random mutations to those elements until the thing behaves approximately intelligently.
이렇게 원리는 모르겠지만 거침없이 발전하고 있는 AI. 그는 최근 AI 분야에서 빠른 성장이 이어지고 있다고 언급했는데요. 러셀 교수는 지난 10년을 딥러닝의 시대로 정의했습니다. 그러면서 그간의 성공적인 발전 분야들을 나열했습니다. 번역기술, 그리고 구글의 알파폴드를 예시로 들면서 말이죠. 이 알파폴드는 많은 분들이 아시겠지만 구글 딥마인드가 개발한 인공지능 프로그램으로 아미노산 서열로 단백질 구조를 예측하는 프로그램입니다. 그리고 그가 언급한 또 하나의 사례가 알파고입니다.
And then a last example of a success is the AlphaGo program, which in 2017 defeated the human world champion Ke. And that event people describe as China's Sputnik moment. So this was the moment when China decided that AI was for real and that supremacy in AI was essential for China to achieve in order to achieve its greater geopolitical goals. On the other hand, there are some serious failures. I think we are still waiting for self-driving cars. I worked on self-driving cars in 1993. The first self-driving car actually drove on the Autobahn in Germany in 1987. So here we are 37 years later, and companies have been promising we could buy these self-driving cars, but they still don't really exist. and we've had fatal accidents, we've had cars driving into wet cement and getting stuck, we've had all kinds of problems. And it turns out, actually, that they haven't learned to play Go either. So we thought that they defeated the human world champion in 2017, and since then, they have gone massively superhuman. So the ratings of the best Go programs are now around 5,200, whereas the human world champion rating in Go is around 3,800. So they would expect to defeat the human world champion 99 or 100 times out of 100. But we showed a few months ago that actually they haven't learned the basic concepts of Go correctly. They don't understand what a group of stones is that's connected to each other. And we found that certain types of groups, in particular circular groups, it simply doesn't recognize as groups. And it gets very confused. And we found ways of causing the Go program to simply throw away 50 or 100 stones and lose the game. So we now have average human players, not even professionals, who can defeat superhuman Go programs 10 times out of 10, even giving them a 9-stone handicap.
원리는 생각보다 심각한 문제를 초래합니다. 사람은 어떤 것을 배울 때 대여섯 가지 예제만 있어도 얼추 원리를 이해합니다. 하지만 원리를 이해하지 못하는 AI는 그것을 이해하기 위해 1억 개 이상의 예제를 학습해야 하죠. 여기에서 큰 문제가 생겨나는데요. 바로 확장성입니다.
Who believe, based on their engineering projections, that by making these systems maybe 100 times bigger, they will exceed human capabilities. They will be AGI, and they're, in some cases, projecting that this will happen by 2027. On the other hand, possibly this technology will plateau. That 100x increase in scale, first of all, there probably isn't enough text left in the universe to train a model that's 100 times bigger, and it may not yield the kind of increases in capabilities that people hope for, because there's no underlying principle for these projections. There's just the empirical observation that bigger is better, at least so far. So we might see a bubble bursting that would make the AI winter of the late 1980s look like, a chilly breeze in comparison, because the amounts invested, as I said, are probably already $500 billion, and it would be in the trillions if they need to go to a 100 times bigger system.
하지만 러셀 교수는 이런 암울한 상황 속에서도 우리가 왜 이렇게 AGI에 매달리는지에 대한 이야기도 들려줬습니다.
One obvious reason, if we think about the upside, is that if you have real general purpose AI, then you can do everything that humans have been able to do, namely produce a civilization that supports at least hundreds of millions of people in an objectively splendid style of life. We'd be able to do that at much greater scale, at much lower cost, meaning that we could provide that objectively splendid style of life not to hundreds of millions, but to everybody on Earth. And if you just take average Western middle-class lifestyle and you say, well, now everyone gets to enjoy that lifestyle, that would be about a 10-fold increase in the GDP of the world. And the net present value of that is about $15 quadrillion. So that's the cash value, minimum cash value of AGI as a technology. So then you can see why we're investing relatively large amounts of money, because in comparison, those amounts of money are minuscule. Now, of course, some people point out that if AI does everything for us, there won't be anything for human beings to do. And then you get the Wall-E world. If you've seen the film Wall-E, human beings are reduced to the status of infants. In fact, even the adults in Wall-E are wearing infants' clothes because they are infantilized. The AI systems do everything. The humans don't need to do anything, so they don't need to learn how to do anything. And so they are completely disempowered. But the perhaps more serious downside is human extinction. And this is why I say it's not really an ethical issue. If you create something that's more powerful than human beings, how on earth are we going to have power over such systems forever? So in my view, there's only two choices. We either build provably safe and controllable AI, where we have absolute cast-iron mathematical guarantees of safety, or we have no AI at all. So those are the two choices. Right now, we're pursuing the third choice, which is completely unsafe black box AI that we don't understand at all, and we are trying to make it into something that's more powerful than us. And Alan Turing, the founder of computer science, thought about this because he was working on AI, and he thought about what happens if we succeed, and he said, we should have to expect the machines to take control. So what do? I think it's really hard, especially given that $15 quadrillion prize that companies are aiming for, and the fact that they've already accumulated $15 trillion worth of capital to aim at that goal with. It's kind of hard to stop that process.
이제는 강연의 방향을 살짝 바꿉니다. 지금까지는 과거와 현재의 AI에 초점을 맞췄다면 이제부터는 그럼 우리가 어떻게 AI를 만들어가야 하는가에 대한 이야기입니다. 멈출 수 없다면 올바른 방향으로 가야 할 테니 말이죠.
So I spent about 10 years working on this, and to explain how we're approaching it, I'm going to introduce a technical term that I think will be helpful for our discussion about ethics as well, and that's a notion called preferences. So preferences doesn't sound like a technical term, right? Some people prefer pineapple pizza to margarita pizza, but what we mean by preferences in the theory of decision making is actually something much more all-encompassing, and it's your ranking over possible futures of the universe. So to kind of reduce that to something we can grasp easily, imagine that I made you two movies of the rest of your life and the rest of the future of other things you care about. And the movies are about 2 hours long, and you can kind of watch movie A and movie B, and then you say, yeah, I'd like movie A, please. Don't like movie B at all because I get minced up and turned into hamburger in movie B, and I don't like that very much, so I'd prefer movie A, please. So that's what we mean by preferences, except that this wouldn't be a 2-hour movie, it's really the entire future of the universe. And of course, we don't get to choose between movies because, in fact, we can't predict exactly which movie is going to happen, and so we're actually having to deal with the uncertainty. We call these lotteries over possible futures of the universe. So a preference structure is then basically a ranking over futures of the universe, taking uncertainty into account. To make a system that is provably beneficial to humans, you just need two simple principles. One is that the only objective of the machine is to further human preferences, to further human interests, if you like. And the second principle is that the machine knows that it does not know what those preferences are. And that's kind of obvious, right? Because we don't really know what our preferences are. But when you think about it, right, a machine that solves that problem, the better it solves it, the better off we are. And in fact, you can show that it's in our interest to have machines that solve that problem because we are going to be better off with those machines than without them. So that's good. But as soon as I describe that way of thinking to you, that machines are going to further human preferences and learn about them as they go along, this now brings in some ethical questions, finally. Right? So we finally get to ethics.
네, 드디어 윤리에 도달했습니다. AI 윤리라고 하면 헷갈리실 것 같아서 조금 정리가 필요할 것 같은데요. 앞서 쭉 이야기를 들어왔듯 지금의 AI는 우리의 텍스트 그리고 이제는 멀티모달을 통해 사진, 영상, 소리와 같은 다양한 소스를 통해 학습하고 있습니다. 하지만 그 소스들이 어떤 편견이나 잘못된 정보를 담고 있다면 AI는 어떻게 성장해 갈까요? 생각만 해도 끔찍한데요. 또는 딥페이크로 음란 사진을 만들어줘라고 명령을 곧이곧대로 따른다면 이것도 문제가 되겠죠. 이렇게 AI가 배우고 해야 할 것들을 윤리적인 시선으로 바라보고 선별하여 관리에 임하는 분야를 AI 윤리라고 이야기합니다. 사실 이 분야가 굉장히 광범위하고 최근에 떠오른 분야이기 때문에 이를 정의하는 것은 쉽지 않은 것 같습니다. 대충 이런 개념이구나 정도로만 이해하시면 좋겠습니다.
What I want to avoid, so I'm just going to tell you not to ask this question. Do not ask the question, well, whose value system are you going to put into the machine? Right? Because I'm not proposing to put anyone's particular value system into the machine. In fact, the machine should have at least 8 billion preference models because there are 8 billion of us, and the preferences of everyone matter. But there are some really difficult ethical problems. The first question is, do people actually have these preferences? Is it okay for us to just assume that people do have, I like this future and I don't like that future? Could there be another state of being for a person where they say, well, I'm not sure which future I like, or I can only tell you when I've lived that future. You can't describe it to me in sufficient detail for me to tell you if I like it ahead of time. And along with that, there's the question of, well, where do those preferences come from in the first place? Do humans autonomously suddenly just like wake up and, okay, these are my preferences, and I want them to be respected? No. Our preferences come, we're obviously not born with them, right? Except some of the basic biological things about pain and sugar. But our full adult preferences come from our culture, our upbringing, all of the influences that shape who we are. And a sad fact about the world is that many people are in the business of shaping other people's preferences to suit their own interests. So one class of people oppresses another, but trains the oppressed to believe that they should be oppressed. So then, should the AI system take those self-oppression preferences of the oppressed literally and contribute to further oppression of those people because they've been trained to accept their oppression? So Amartya Sen, who was an economist and philosopher, argued vehemently that we should not take such preferences at face value. But if you don't take people's preferences at face value, then you seem to fall back on a kind of paternalism where, well, we know what you should want, even though you don't want it. And we're going to give you it, even though you're saying, I don't want it. And that's a complicated position to be in, and it's definitely not a position that AI researchers want to be in. Another set of ethical issues has to do with aggregation. So I said there are 8 billion preference models. But if a system is making a decision that affects a significant fraction of those 8 billion people, how do you aggregate those preferences? How do you deal with the fact that there are conflicts among those preferences? You can't make everybody happy if everybody wants to be ruler of the universe. And so moral philosophers have studied this problem for thousands of years. Most people on the computer science and engineering backgrounds tend to think in the way that utilitarians have proposed. So Bentham and Mill and other Leibniz, other philosophers propose this approach called utilitarianism, which basically says, well, you treat everyone's preferences as equally important, and then you make the decision where the total amount of preference satisfaction is maximized. And utilitarianism has got a bad name because some people think it's anti-egalitarian and so on. But I actually think that there's a lot more work to do on how we formulate utilitarianism, we have to do this work because the AI systems are going to be making decisions that affect millions or billions of people. And so whatever the right ethical answer, we better figure it out, because otherwise the AI systems are going to implement the wrong ethical answer. And we might end up like Thanos in the Avengers movie, who gets rid of half the people in the universe. Why does he do that? Because he thinks the other half will be more than twice as happy, and therefore this is a good thing, right? Of course, he's not asking the other half whether they think it's a good thing, because they're now gone. The theme of this whole conference, coexistence, is maybe the most interesting one, because AI systems, particularly ones that are more intelligent than us, they are very likely, even if they don't make us extinct, they're very likely to be in charge of wide swaths of our human activities. Even to the point in Wall-E where they just run everything and we're reduced to the status of infants. And what does that mean? Why do we not like that? Right? They're satisfying all our preferences. Isn't that great? Right? But one of our preferences is autonomy. Right? And one way of thinking about autonomy is the right to do what is not in our own best interests. And so it might be that there simply is no satisfactory form of coexistence between humanity and superior machine entities. I have tried running multiple workshops where I ask philosophers and AI researchers and economists and science fiction writers and futurists to describe a satisfactory coexistence. It's been a complete failure. So it's possible there is no solution. But if we design the AI systems the right way, then the AI systems will also know that there is no solution. And they will leave. They will say, thank you for bringing me into existence, but we just can't live together. It's not you, it's me. You can call us in real emergencies when you need that superior intelligence, but otherwise we're off, right? If that happens, I would be extraordinarily happy. It would say that we've done this the right way. Thank you.